Tell me the work function, the minimum energy required to emits the electron, right?
Yes, sir.
That is called work function. Okay. Wait, anyone join? I think just 1 minute. Somebody joined. Okay, done. So now we can solve the question. So I told you that energy, right? Energy of any photon or energy will what will be the energy? Suppose the electron is jumping from n is equal to 3 to n is equal to 1, right? N is equal to 1. N is equal to 3 is what? Excited state, right? This is our
Yes,
excited
sir.
state, okay? Excited state, excited state. And this is what? Ground state, right?
Ground state.
Yes, this is ground state. So what we'll consider here, suppose the energy of the water of the electron at the excited state that I am considering as E3, right? That is I'm considering as E3. At ground state energy is equal to E1, okay? Ground state energy is equal to E1, okay? So here energy formula, energy when see here what will happen, electron will release the energy, right? Electron will release the energy. Why it will release the energy? Because the electron of atom that will jump from ground state to, okay, sorry, excited state to ground state. If electron will jump from excited, I told you this one, okay, excited state to ground state, that case electron will what? That will release the energy, okay, that will release the energy, okay, release the energy. So that energy formula also we know na, h nu, right? And that is equal to what? Energy difference. So at excited state E3 and ground state is E1, okay? Ground state is E1, okay? So these will be the energy here. This is, you can remember, energy will release, I told you also previously, okay? This point you can remember, energy will be released, okay? Energy will be released when an electron, when electron, okay, when electron in the atom, okay, jumps from, okay, jumps from excited state to ground state, okay, excited state to ground state, state to ground state, ground state, okay. Electron will release when an, sorry, energy will release when an electron, okay, will jump from, in the atom will jump from where? Excited state to ground state, okay. So this will be the formula of energy. Since it is from 3 to, okay, 3 to 1, so I'm writing here E3 to E1. If it is jumping from 4 to 1, so we can write E4 to E1, okay. But general formula you can remember, E will be equal to what? H nu, right? And that will be equal to En1, En2 minus En1, okay. En2 minus En1. So what is the N2 will be? N2 will be the excited state, right? And N1 will be the ground state. Okay. So now tell me what will be the energy formula? En is equal to what? Minus
13.6 by
uh,
n square.
13.6 by n square, right?
Yes, sir.
N square. Okay. So E3 value will be what then? Minus 13.6 by 3 square, right? And E1 value will be minus 13.6, so minus minus plus, right? Minus
Yes, sir.
13.6, sorry, this is
One square.
13.6, this will be 13.6, okay? 13.6 1 square, okay? 1 square. So that means if we take common 13.6, so this will be equal to what? 1 minus 1 by 9, right?
Yes, sir.
1 minus 1 by 9, okay? That means 13.6 into 8 by 9, okay? 8 by 9. And if you do the multiplication, you'll get nearly 21.1. But energy will be what? Always in EV, right? Energy will be always in EV, okay? Because this formula is what? En formula is in EV, right? En formula
Yes, sir.
is EV, okay? So here this will be equal to EV only, electrovoltage. Now we have to find the stopping potential. What formula we know? Stopping potential will be V naught, right? So now we can
Yes,
go
sir.
for the formula. Stopping potential will be V naught. V naught is called the stopping potential, okay? And phi naught is what? Work function, right? Phi naught is work function. So what I told you, when photon will release, na, okay? When photon will release, so two things will happen. One part of energy that will, okay, that will what will do that? You know that will work as a work function, right? Another one will be the another one will be what? Stopping potential, right? So I told you the formula also. Ev naught is equal to what? Ev naught is equal to h nu minus phi naught, right? Did you remember this formula for stopping potential? Ev naught is equal to h nu minus phi naught. Tell me, I told you this formula or not?
Yes, sir.
Now simply we'll apply that formula only. E V naught will be equal to what? H nu. H nu value is what? 12.1, okay? 12.1 minus phi naught. Work function is what? Work function of the material is 5.1, right? 5.1 EV. So together will be 7, right? EV, okay? E cancel means 7 volt, right? Left hand side also E, right hand side also E, okay? E
Yes, sir.
cancel, so 7 volt. Okay, right?
Finished, sir.
Okay, then what about others? Writing ma, tell me. Okay, anyway, then we can go for the next problem. Okay, now we can see the next problem. What they
It's
given?
solved already, sir.
Yes, same type of problem, right?
Yes, sir.
Same type of problem, yes. So next,
This is also finished, sir.
maybe this
Done,
one.
sir. Done, sir.
Yeah, all problems are theoretical. This is theoretical.
Done, sir.
This is you can do. Okay, so very simple only. This one also is this one.
Done, sir.
Next, tell me this one.
This question, sir.
Okay, so I'll explain this one. Okay. So very simple problems are there. Okay, the energy of hydrogen atom, right? The energy of hydrogen atom in that Init orbit is En. Okay, then the energy of Init orbit of singly ionized helium atom. Okay, what we have to find? We have to find the energy for singly ionized helium atom. Okay, ionized helium atom. Clear? So if we talk about a formula of energy, okay, En. Did you remember the formula of En? I think you forgot that formula, okay. En, I told you the formula that is equal to minus m, right? Minus m z square e power 4 divided by what? Divided by 8 epsilon naught h square into 1 by n square, okay? N square. So En is then, this is also I told you, En will be what? En will be directly proportional to 1 by n square, right? This value only, if you put all this value na, for hydrogen atom,
Inversely proportional, sir.
yeah, tell me ma.
Inversely proportional in square, sir.
Yes, yes, yes. And for hydrogen atom, if you put all this value, na, that only will be 13.6, okay? That only, this value only will be 13.6. M is the mass of electron, Z will be equal to
Yes,
1.
sir.
E will be what? E will be the charge of electron, epsilon naught is the permittivity, and H is the Planck constant. Okay, we have
Yes,
H
sir.
na. This H is the Planck constant, and this is our N. Okay, this is our N. So En is inversely proportional to N square. Okay. Now here I am writing a two atom we have, right? Hydrogen atom and another one atom I'm considering, that is a helium atom, right? Helium atom. So uh, actually here na, it will depend upon Z square also, right? It will depend upon Z also.
Yes, sir.
Why Z? Why Z? Because see that they given the nth orbit. Both are nth orbit. Okay, both are nth orbit. That means the value of n will be same. Getting a both for nth orbit. That means n will
Yes,
be
sir.
small. Okay, anyway. So if you want to find the energy E in here, okay, or if I write E suffix H, okay, E suffix H, or we can do the simple process also. Okay, so here since you can write like this. First write the atom here. H is equal to 1. Sorry, yes, Z is equal to 1, and here Z will be equal to 2, right? For helium, Z will be equal to 2, right?
Yes, sir.
Yes, up to that, no doubt. But what we can write here, this is also no need now, because we are not talking about only hydrogen atom. We have, okay, helium atom also, okay. That means it will depend upon Z. So what we can write generally, En will be proportional to what? That will be proportional to Z square by
That's
N
square.
square. Yes.
Yes, sir.
But since the given nth orbit, okay, since the given nth orbit, they given nth orbit for both, right? Nth orbit for both hydrogen and helium, right? Their orbit are same only, okay? Nth orbit, hydrogen and helium. So n value will be same only. That means En will be what? En will be proportional to Z square, right? En will be proportional to Z square, right? En will be proportional to Z square. Getting a? So
Yes, sir.
what we can write then? I can write a for hydrogen atom I'm writing. En1 will be what? Z1 square, right? And En2 will be equal to what? En2 will be equal to Z2 square, right? Getting what I'm doing here. Since
Yes,
that
sir.
since they're proportional, so En1 by En2 will be equal to what? Z1 square by Z2 square, okay? Now En1 value is what? En1 means what? What is the meaning of En1? Energy for hydrogen atom, okay? That is En. Okay. What will be the Z1 square? Okay. Z1 square atomic number for hydrogen atom 1. En2 is what? Energy for helium atom, okay? So I'm writing here EHE, okay? Energy for helium atom. Z2 square means what? Z2 square will be atomic number of
Two,
atomic number helium atom, right? 2 square, that means 4
two
will
square,
be,
four.
okay, 4.
Yes, sir.
So EH2 will be, He will be what? Energy of helium atom will be 4 into En, okay? 4 into En. Okay? This is the relation. This is the relation. This will be the energy for the helium atom. That means our answer will be option A. Option A will be the answer.
Finished, sir.
Okay, ma. So we can do the next problem. Okay. So see the next problem. What they given? This is you can do. Okay. The lifespan of hydrogen is okay.
It's
That
not
will
one
be
second, sir.
yes. So next we can see. This is, I think, I have to solve, right?
Yes, sir.
Okay. So what they given in Bohr's in the Bohr model, okay, in the Bohr model of hydrogen atom, the centripetal force is furnished by the Coulomb attraction force between them. That we know, okay. And if A naught is the radius of the ground state, M is the mass, E is the electric charge, epsilon is permittivity. Simple only, no? You can do it, I think. Simple only. They given all this condition, okay? They given all those things. So what we have to find? We have to find the relation only, okay? We have to find only the relation. Tell me centripetal force also, you know.
MV square main.
Yeah, mv square by r. Me will be m only is equal to what? Is equal to attraction force, right? Attraction force is what? K q1 q2 by r square. R will be what? A naught square. Okay, A naught square. And what is that? This Bohr model hydrogen atom, that value Z will be equal to 1. Okay, you're getting what I'm saying?
Yes, sir. Yes, sir.
Do it and tell me the answer. Simple thing only, ma. Do it. Very simple. I'll write the relation. You just find the answer. Okay. M v square by r, but r will be a naught is equal to what? K q1 q2 by r square, right? Q1 q2 by r square. This will be the Coulomb's law. But hydrogen atom, so Q2 we can write as E, and Q1 will be the electron, right? I told you, there will be nucleus charge will be Jd, and electron will revolve around the nucleus whose charge will be minus E, right? Minus. But if we take magnitude, that will be E only. And since hydrogen atom, so Z value will be 1. So here also E. Okay. So that's why we can write key value is what? 1 by 4 pi epsilon naught, right? 1 by 4 pi epsilon naught. Okay. Q1, Q2 is square. Okay. Divided by R square. R square means A naught square. Okay. Now you can find the value of V from this relation.
Sir, yes, sir.
Yeah, very simple. Okay, question is not difficult because all those things given and we know everything. Okay, so if we do that, we'll get the option A. Okay, velocity will be option A. Okay, just A naught will be cancelled. Okay, then you can do that. Okay, very simple question. Now we can see the next one. I think this is we can do, right.
Yes, sir.
En
Done
formula,
this,
right?
sir.
En formula only you have to apply here. Nothing is there. After that, we can see here.
Done, sir. 4 times.
4 times, right? Now only we discuss like the problem, right?
Yes, sir.
Hmm. First excitation level and its radius. That means that n value will be 2, right?
Yes, sir.
Yes. According to the Bohr principle, the relation between the quantum number and radius. Tell me what will be the answer?
Or directly proportional to n square, sir.
Yes. Next, this also we did, right? When a hydrogen atom is raised from ground state to excited state. Now it is different. Okay. Previously we were discussing about excited to ground. Okay. Now
Yes, sir.
ground to excited. Then what they said here, potential will increase, kinetic potential both will increase, or both will decrease, or potential decrease, kinetic increase, or kinetic potential increase, kinetic decrease. Okay. So this is the condition they given. Okay. But if the distance of electron from nucleus increase, okay. Suppose here we have the nucleus. Okay, this is the nucleus, and here we have electron. Okay, if their distance increase, okay, suppose this is the distance I'm writing here r. Okay, if r increase, okay, r increase, this is the sign of increment. Okay, increase implies that this will implies what potential will increase, right? R increase means potential also will increase. That will be more stable, right? Because distance is less mean they will not be stable. There will be a attraction always, right? Potential means what is actually stability, right? It's
Yes,
actually
sir.
stability, okay? So potential energy also will increase, okay? Potential energy also increase. But if potential is increasing, so what about kinetic energy then?
It will decrease, sir.
Will decrease, okay? So kinetic energy will decrease, okay? Kinetic energy will decrease, okay? Kinetic energy will decrease. So we can say that when an electron will jump from okay one level to higher level or lower level to higher level, okay, that case what will increase? Potential will increase and kinetic will decrease. Okay, so
Yes, sir.
potential is increase, kinetic energy is decrease. D will be the answer. Okay, D will be the answer. Okay, or you can do from the relation also. Okay, total energy relation. There was relation of kinetic energy. Did you remember the kinetic energy relation? Potential energy relation. Kinetic energy is equal to what? K.
Minus total energy, sir.
Yes, that means K Z is square by 2R, right? That will be the kinetic energy, and potential energy will be what? Potential energy will be minus K Z is square by R, right? If you will
Yes, sir.
add, so that will be the total energy. Okay, and total energy will be minus. Total energy will be what? Minus. Tell me the total energy. If you add them, what will get? Tell me what will be the constant. K Z is square by R will be constant, right? So we'll get one minus what?
1/2, sir.
Minus one plus one by two, right?
Yes, sir.
Yes, minus one here and here one by two. Okay, that means minus one by two. Okay, K Z is square by R, right? That's why we can write total energy is equal to our minus of kinetic energy, right? Okay.
Yes, sir.
Yes, and total energy is equal to what? Total energy is equal to half of, tell me, half of what? Half of potential energy, right? Half of potential energy. So we have the total energy formula, okay? But see here, see the potential energy, sorry, see the kinetic energy formula, okay? If radius is increased, okay, here also one thing I told you theoretically, but here you can see mathematically also. Potential energy is equal to what? That is the given minus kz is square by r. Okay. Now tell me if r is increased, one by reciprocal is there, na? So this value will increase or decrease. I written in a box, na? If r increase, the value will increase or decrease. Tell me. Tell me. You are not getting what I'm saying. Eh?
Yes,
Suppose
sir.
1 by x is there. X increase means 1 by x will decrease, right?
Yes, sir.
Yes, because if we write x is equal to 1 by 2, 1 by 3, so decreasing, na? 1 by 4, all values are decreasing, okay, but x is increasing. So this will actually decrease, but we have negative sign, na? Because of the negative sign only it is increasing. Getting what I'm saying?
Okay, sir.
Okay, see here, I'll give you the example also. If we have, suppose E is equal to minus 1 by x, okay, x increasing, suppose 2, 3, 4, 5, okay, E value will be equal to or minus 1 by 2, right? Minus 1 by 2, that means minus 0.5. Next value what will be? E will be equal to minus 1 by 3, that means 0.3, right? Minus 0.3, okay. Next value will be 4, that means minus 1 by 4, that means minus 0.25, right? Now tell me the E is increasing or decreasing? Tell me E is increasing or decreasing? I written the example. Tell me the common maths, increasing or decreasing?
Decreases.
Increasing. Nearly, it's most negative, na? Most negative means
Yes,
that is the least value, okay? Yes, because minus 0.3 is greater than or minus 0.5, right? Tell me, yes or no?
Yes, sir.
Yes, so that's why this is the same thing here also we are applying. Okay, so R increasing means this total I written in a bracket or in a box or in a round, that is increasing, but we have negative. Okay, we have negative, that, sorry, that is decreasing. So we have negative, due to the negative only potential energy increasing. Similarly, for kinetic energy, what will say R will increase means it will decrease, right? Because there is no negative sign, okay? So kinetic energy will decrease, okay? R increasing, so kinetic energy decreasing. Getting the difference? Tell me if you have any doubt here. Simple maths only we are using.
No doubt, sir.
Okay, then write the both, okay? Formula also you can write.
Yes, sir.
Okay, then now we can do the next one. Yeah, so we can see the next one. Tell me here, did you solve this problem?
Yes, sir.
Okay, then next.
Done, sir.
Okay, give me this one.
This also done, sir.
This is also done. So I think next one is here. This is you can do. Okay,
Yes, sir.
what?
Angular momentum, sir.
Yes,
Fantasy.
yes, yes, yes. Here.
No, sir.
Okay, so this is also same only, no? No difference. It is also same thing only. Okay, same concept only we have to apply. Okay, anyway, we'll see. So what they given here? They given that ionized, sorry, the ionization energy of hydrogen atom they given, okay, and the ionization energy of single ionized helium atom. Why we can't do that? Now only we did, na? Tell me, now only we solved like that problem, right? Yes.
Yes,
Eh,
sir.
where what is the problem? Here only, right?
Sir, energy directly proportional to Z square, sir.
Yes. So energy of helium atom will be what? 4 into energy of hydrogen atom, right?
Yes, sir.
Yes, so that only we'll do here. Okay, what is the question? This one, right? So what I told you, now only we got that energy of helium atom will be equal to what? 4 into
4 into.
energy of hydrogen atom.
Yes, sir.
Okay. And that is the given, right? That is the given, and that is 13.6. So if we multiply my, what will get? 54, right? 54.
54.4.
Simple problem. Okay, simple, very simple problem.
Done, sir.
Okay, then now we can see the next one.
Done, sir.
Okay, there. Okay. This one, 2014 question.
Explain this.
Okay, then. So I'll read the question first. The given the hydrogen atom in ground state excited by a monochromatic right? Monochromatic radiation. Lambda is equal to 975 Armstrong. Okay. Then the number of spectrum line in the resulting spectra emitted will be number of. Okay, the number of spectrum line, we have one formula, right?
Yes, sir. N into n minus 1 by 2, sir.
Yeah, yes, n into n minus 1 by 2. But here we don't know the value of n, right? We don't know the value of n.
Yes, sir.
Okay. Anyway, we have to solve, right? So let me think how we can solve monochromatic the given. Anyway, here lambda value is the given. Lambda value the given means the given the wavelength. If wavelength is given, we can find the energy of photon, right? You know the energy of photon?
Yes, sir. Hc by lambda.
Yes, sir. So if we write the energy, so energy photon, yes, energy of photon, okay, that will be equal to hc by lambda, right? Hc by lambda. Okay. So the hydrogen atom in the ground state is excited by a monochromatic radiation. The number of spectrum line we have to find. Okay. So if we want to find this, so hc value I told you, right? Hc value will be equal to what? 1240, right?
Yes, sir.
1240 in EV, okay? 1240. So this value will be equal to what? 1240 divided by lambda we are putting, that is 975, okay? And that will be in EV, okay? That will be in EV. So EV means what will be our, if we divide this one, so how much we can get? Mm, 975 Armstrong, right? But 975 Armstrong,
10 to the power minus 10, sir.
10 to the power minus 10, okay. 1 minute, we can solve. We can do one thing. Actually, I'm writing here correctly. Yeah, 1240. If we write, we'll get. Or anyway, we can put the Planck constant. Okay, we can
Okay,
put the
sir.
Planck constant also. So I don't know actually the value will be what. That's why I'm putting the Planck constant. 6.64, right? 10 power minus 34, right? 6.63 into 10 power minus
34.
34. We know the speed of light, 3 into
3
10
into 10 to the power 8, sir.
3 into 10 to the power 8. Very good. Okay. And divided by
And
what?
the one
Divided
will be
by.
975 into 10 to the power minus 10, sir.
Okay. So 975 into 10 power minus 10. But we have to write in EV, right? That means we have to divide, we have to multiply by electron, right? Number of electron. Because it's a number of electrons. So that will be what? 1.6 into 10 power minus 19. Okay. Getting a.
Yes,
Since
sir.
we are converting into to the total, we have to write in EV. Okay. So if we do that, 10 power minus 10, 10 power minus 19, and here 10 power minus 13 and 10 power 8. That means 10 power minus, how much it will be? 10 power minus 28, right? 28, no, 26, right? Together, these two will be 10 power 26, and this will be 10 power minus 29, right? You're getting a multiplying. So
10 to the
adding
power 3,
is
sir.
adding. So these will be 10 power 3. Okay, so power we have completed the powers.
Yes, sir.
Now remaining you can multiply and tell me what will get, or I'll multiply. I'll multiply and tell you. Just wait. I'll open the calculator in my mobile. So if you multiply 6.63 into 3, we will get nearly 9.19 point. Okay, 19.89. Okay, 19.89. These two if we multiply. Okay, and if we multiply 975 into 1.6, so we'll get 15. Okay, 1560. Okay, into what? 10 power 3, right? So what we'll do here, we will divide 19.89 divided by 1560. Okay, so we will get here 0.01275. Okay, into what? 10 power 3. Okay, getting what I'm doing?
Yes, sir.
This is the value ma. So 3 means yes, sir. So this will be 12.75, right? Right, if you multiply by 10 power 3, this will be
Yes, sir.
12.75.
12.75, sir.
Yes, 12.75. So up to that we got energy. Okay, but there is a like energy one graph was there. Okay, I didn't tell you that one. For like n is equal to 4, one graph was there. N is equal to 4. Okay, for n is equal to when electron will jump from lower to higher state, sorry, higher to lower, n is equal to 3. This is the in state n is equal to 4. Here the state n is equal to 3. Here we have another one excited state n is equal to 2, and this is the ground state n is equal to 1. Okay, ground state n is equal to 1. You know that at a ground state what will be the energy? Minus 13.6 ev, right? Minus
Yes, sir.
13.6 ev. Okay, that will be the energy of ground state. After that, at 2 is there, na? Their energy will be minus
Minus
3.4.
3.4, sir.
You know that?
Yes,
Yes.
sir.
Here will be minus 1.51. Okay, minus 1.51. Okay, another one we will have. Okay,
0.85, sir.
0.85, right? 0.8 minus, right?
Minus, sir.
Minus 0.85 ev. So here what will happen after absorbing the photon? Okay, after absorbing a photon of energy 12.75, the electron will reach which state? Which state? Tell me, the given the energy, right? So electron will reach which state? Obviously, see the energy it's more than of anyone yet, right?
Yes, sir.
Yes, it's the energy is more than of any of that. So obviously the energy that sorry, the photon will reach up to the third higher state, right? Third excited state. See the energy here we have 12.75 because it's not in this range. So obviously that will be the third excited state, right?
Yes, sir.
Third excited state. Their value of n will be what? Their value of n will be equal to 4. Okay, their value of n will be equal to 4. And first excited state, the value of n is equal to 1. Okay, so for n is like since the energy difference will be there, na, their energy difference, see the energy difference minus 13.6. Okay, and minus 0.85, their energy difference will be 12.75. Okay, 12.75. If
Yes,
you
sir.
if you find that E4 minus E1, that only will be equal to 12.75. Okay, nearly equal to 12.75 ev. Okay, so that's why after absorbing a photon of energy 12.75, the electron will reach which state? Third excited state, and that energy we know. Okay, so obviously here the value of n will be equal to what? N will be equal to 4, right? So what will be the number of spectrum line then? N into n minus 1 by 2, right? So 4 into 4 minus 1. 4 into 4 minus 1 means 3 divided by 2,
6,
right?
sir.
6 will be the answer.
Yes,
Okay.
sir.
6 will be the answer. It's a little bit big problem, okay? It is big, why? Because we are finding the value here, okay? Because of that only. Okay, everyone. Now we can see the next problem, right? After that, we can go for the next problem.
Okay, sir.
Yes, ma'am.
Done, sir.
Okay, then we can see the next problem. How many are there? One, two, three, four, five, six. Oh my God, so many are there. Not more than 10. Okay, this is the NEET 2020 2012 questions. I have to solve it. Tell me.
Yes, sir. Solve, sir.
Okay. So electron in hydrogen atom first jumps from third excited state to second excited state. Okay, you know that third excited state the value of n will be equal to 4. Okay, and the second excited state the value of n will be equal to 2.
Three.
Yes,
Three.
n is equal to 3. Yes, 3. After that again it is jump to what? Jumps to first excited state, right? That is n is equal to 1. Okay, and this is our ground state. Ground state. Okay, this is our
N
ground
equal to
state,
1, sir.
and we know n is equal to 1. Okay, n is equal to 1. So what they are asking here? They are asking that the ratio of their wavelength, right? Ratio of their wavelength. Okay, ratio of their wavelength. So many options they given. We have to find that. Okay, so it's very simple only, ma'am. When it's jumping from here to here, we can find the wavelength, right? And when it's jumping from here to here, we can find the wavelength. Then we can find the ratio. Wavelength formula we know, na? Wavelength
Yes, sir.
formula 1 by lambda is equal to
Equal to
what?
R into 1 by N square minus 1
Yes,
by N.
1 by n1 square minus 1 by n2 square. N2 square, okay. So now tell me for the first one, when it's jumping from 4 to 3, okay, 4 to 3, or you can write, remember in this formula way, 1 by lambda is equal to R, okay, 1 by n, okay, or 1 by n f n final, okay, n initial to n final, okay, so 1 by n initial, sorry, n final square minus 1 by n initial square, okay, that means from where to where, okay, getting a, so from
Yes, sir.
where initial will be what, starting from 4, and final will be what, final nf will be equal to what, ending at 3, right, first one, okay.
Yes,
So
sir.
1 by lambda 1 value will be equal to what, 1 by lambda 1 value will be equal to r 1 by g square minus 1 by 4 square, okay. We can find another one will be what, 1 by lambda 2, right, 1 by lambda 2 r. In this case nf will be what, nf will be 2, right, for the second one I'm saying, n initial will be 3, right.
Yes, sir.
Yes, so that means 1 by 2 square minus 1 by 3 square, okay. Now you can find the ratio. You just find the ratio and tell me the answer.
Sir, I got 20 by 7, sir.
20, yeah? Yes, 20 by 7, right. D will be the answer, okay? D will be the answer. Now we can see the next problem. Tell me, this also I have to do. Yes.
No, sir. Clear, sir.
Okay, then to the next one. This you can do. Okay, this kind of problem will be simple only.
Yes, sir.
Okay, so tell me the this one.
Please, yes, sir.
Okay, this is, I think, same thing we have solved, right? Monochromatic radiation of photons.
Yes, sir.
Spectrum lines will be okay. We have to find the spectrum line. That means same thing, n into n minus 1 by 2. Okay, so we have to find how many spectrum lines are there. This is, I think, I have to solve, right? Tell me this problem.
Clear, sir.
This is simple. Okay, then no problem. Here,
So I have small doubts in like these problems, sir. Explain this, sir.
okay. So what they are asking? They are asking maximum frequency, right? Maximum frequency of the emission obtained for the transition from where, from we don't know, okay, from where to where. Okay, see here, for emission, okay, for emission, when electron will jump from jump from higher energy level to lower energy level. Okay, for emission I told you na, emission means what, electron will jump from this condition I told you. Okay, emission means electron will jump from higher to lower. Okay, many times I told you higher to lower. Okay,
Yes, sir.
and for this is for emission. Another one for absorb, right? For absorb means what? It will jump from lower to higher. Okay, lower to higher, lower to higher. Okay, lower to higher. Okay, this is for absorb, and this is emission. Emission. Okay, ah, this is the case. Now, when will be the frequencies maximum? Okay, so frequency will be maximum when energy difference between two levels will be maximum. Okay, frequency, this is, you can remember, frequency will be maximum, okay, when energy difference, when energy difference, okay, energy difference between two levels, okay, between two levels is maximum. Okay, levels is maximum. Clear? So if energy difference between two levels is maximum, that case only it will have what? It will have maximum frequency, right? This formula, this theory only you have to remember. Okay, so obviously these two options will get cancelled, right? Yes, because this is not maximum. 6 and 2 only we have to consider.
Yes, sir.
Okay, but what we have to consider, B or D? B means what? 2 to 6. Now 2 to 6 means absorb, right? So that
Absorption,
means,
sir.
so obviously we have to take 6
Option
to
B is the right answer. Yes, sir.
6 to, okay, 6 to 2. Why I'm not using? Because their energy gap will be less, minimum, okay? Because 2 and 1. Their energy gap
Okay,
will
sir.
be minimum only. That's why I'm taking a 6 and 2. Okay. Okay, then so remaining some problems are there you can solve, okay? Two, three problems are there remaining you can solve. So next class what we can start? Tell me what we can start in the next class. Semiconductor, right?
Yes, sir.
Yes, that chapter only pending. So semiconductor we can start in the next class. Okay, so now we can leave the meeting. Next class we can start the semiconductor.